to start, I'm gonna just start by coding a poodle class and like a lab class, like the two dogs, and you're gonna see like a bunch of repetition, and you're gonna see why inheritance is a thing. So to start, I'm gonna go class poodle. And it's gonna take in a name for a dog. It's gonna take like a color, and it's gonna take in a size. Right? And then I'm gonna say self.name. Oh yeah, sorry, thank you.
Yeah.
Self, and then I'm gonna say self.name equals name. Self.color equals color, and self.size equals size. Okay, and then I'm gonna create like a bark method, and what that's gonna do is just say I'm a poodle, right? So I'm gonna just return I am a poodle. Okay, so now I have a poodle class, and it's gonna make a poodle, and it's gonna bark like I'm a poodle.
Are you recording?
Yes, I am.
Sorry.
That's okay. And then I'm gonna create a lab class, and it's basically gonna be the same exact thing. It's just gonna say I am a lab instead of I'm a poodle. So I'm gonna repeat all of this code. I'm gonna be like class lab. I'm gonna do def in it. I'm gonna pass in self, name, color, and size. And then I'm gonna do self.name equals name, self.color equals color, self.size equals size. And then I'm gonna have the bark method. And then I'm gonna just return I am a lab. Okay, so you saw how long that took to create like two really similar classes that have basically the same exact features. It's just like the difference between like one being a poodle and saying I am a poodle, and the other being a lab and saying like I am a lab, right? So that's what inheritance determines like to solve. So it's basically inheritance is like a relationship between two classes, and it's essentially like a parent-child relationship. So pretty much how like you guys, and if you have siblings, your siblings are very similar to each other in terms like to your parents in terms of like you get certain features from your parents that are similar between the two of you, such as like hair color, eye color, height, weight, even maybe. But you have certain features that are different. We can do the same thing with classes and like generalize it so that it has a parent class that has all these certain features. And basically what will happen is like there will be a parent class that will take in the similar features, and we can just use them in the child classes. So the parent-child relationship entails that like everything that the parent has, the child can get, but not everything the child gets, the parent gets. And that like basically forms the foundation for this like is a relationship. So to kind of specify that, I'm gonna create a parent class, it's gonna be dog. And basically what this is gonna do is like the same exact thing. So I'm gonna have a class dog now, and it's gonna be, it's gonna take in the same exact features as what we did before. So every dog's gonna have a name, a size, or a color and a size, right? And it's gonna have the same exact thing. It's gonna say self.name equals name, self.color equals color, and then self.size is gonna equal size, right? And then I'm gonna probably have like a bark method again, but this time since it's like generalized to just like all dogs, I'm just gonna return I am a dog. Okay, so this is the parent class. It's going to be called dog. So now what I can do is I can go back into poodle, and I can pass in dog. And then now I can essentially just like say I decide to delete all this and just put in pass. And say I want to like create an instance of poodle. So say I have D equals, poodle. And then I pass in a name like poodle. I pass in color brown, and then I pass in a size small, and then I decide to say d.bark. Okay, so what do you guys think that doing this will do? Like, what will the code produce? Yeah, yeah. So what I'm essentially trying to show is that like everything, if I inherit from dog, like if Poodle inherits from dog, Poodle's gonna essentially just get everything that's in this class. So if I decide that I'm gonna make a new Poodle, I'm gonna basically be taking everything from dog's constructor here. So it's gonna assign Poodle to the name, it's gonna assign brown to the color, it's gonna assign size to small. And then when I call the bark method, it's basically just gonna return, I am a dog, right? So that's basically describing this parent-child relationship where like the Poodle is gonna get everything from dog. But what about the part where like the Poodle has certain features that are different from dog, for instance? So say like my lab, you know how I say I am a lab? Say that I also have like a feature here that's unique to labs where it's like, I don't know, whether or not it has a bow. So like has a bow equals true, or just has a bow. So say I want like this to always have a bow. Yeah, say I want this to like always have a bow. So something else with inheritance is that like you can override methods and like instance variables. So the thing is like with this bark method here, if I was to create a new lab, let's say outside of my class, if I'm going to create a lab and I'm going to pass in like lab brown, small, and like true, and then I decide that I'm going to bark. So right now, like lab's bark is different than dog's bark, right? Lab's bark says I'm a lab and dog's bark says I'm a dog. So when I call this method bark, it's gonna go immediately to the child class and check if that method is there. So when it goes to the child class lab, it's gonna ask, okay, lab is a dog, but does lab have its own bark method? If so, I want to execute lab's own bark method because I don't want to go to the parent for no reason. If the child's unique, why am I going to go to the parent, right? But if it doesn't have a method, then it's going to do what Poodle did, right? So in this case, it's going to ask, okay, well, a Poodle is a dog, but this Poodle doesn't have any sort of bark method. Okay, well, maybe its parent has a method. So then it's going to go to the dog class. It's going to be like, okay, do I have a bark method in the dog class? Yes, I do. So I'm going to return I am a dog.
So it's like coming up a tree.
Yeah, pretty much. Yeah. So it's this huge tree of like children and then parents. And it's gonna start at the bottom and check if it's there. If it's not, it's gonna climb up. Yeah, so that's overriding a method. The next thing I want to talk about is the super call. So super, what that's gonna do is it's gonna basically make a call to the parent. So like super, in this case, essentially is just being like dog. And basically what that does is it allows like the class to immediately go up the tree to the parent and use that method. So you know how I have all this like repeated code here that's in like lab class, but it's also in the dog class where it has name, color, and size. So instead of doing that, what I can do is I can just replace all this with super dot init, and I can pass in name, color, and size. So what that's gonna do is it's gonna, once a lab is created over here, it's gonna go to the super class dog and it's gonna call this init method on this name, color, and size over here. So then it's gonna create a new instance of the lab, and then it's gonna assign self.hasbow to hasabo, which is passed in over here, and then it's gonna call d.bark.
So in that first init, do you have to define all of those